I've basically just started working with the Crowther lab about 6 months ago now, but I've been working in restoration ecology for over 10 years now. And I just wanted to basically give some general overviews about the importance of protecting and restoring the world's forests, and then talk about some big tools that the Crowther lab has put together to try to basically create a social network of restoration to get everyone working together. So Ravinder gave a great background here, but I just wanted to kind of give you a sense of where I'm coming from. So I started working in temperate forests in New England, and then really my big focus has been in the tropics. So worked in both northern and southern Costa Rica, and now I've worked a bit in Hawaii too. And then now I'm really focusing a lot of my work on the Yucatan Peninsula in tropical dry forest in Mexico. So working with Plant for the Planet, which is a really big, large-scale tree planting organization that works in collaboration with lots of different groups. We're doing a really large-scale reforestation project in degraded forests in Mexico. And we're doing a lot of experiments to try to understand how to best restore forests and plant the right tree in the right place. And this takes a lot of really excellent people. So this picture on the bottom right-hand side is our really incredible field crew and all our restoration ecologists from Mexico that we work with. And I just wanted to really acknowledge them up front because all of this work would not be possible without them. And I just wanted to give a little bit of background on how people talk about ecological restoration. So restoration in general is this process of recovering damaged ecosystems, but people think about this in two main ways. So either passive, which people call natural recovery, or active, which is assisted recovery. So ecosystems have just tremendous capacity to recover on their own. So really trees can be planted by the forests themselves, and this is the most natural way, obviously, for it to happen. But sometimes ecosystems are really degraded, and this is where this assisted or active assistance kind of comes into play. And this is where we talk about actually planting trees and doing really kind of intense management interventions. So as restoration ecologists and just scientists in general, what we try to think about is what's the best way to implement these different types of restoration. When should we do tree planting? When should we just let ecosystems recover on their own? And when should we really use a combination of all of them? And this has really come to a head recently with all of these countries kind of committing to end deforestation at COP recently. But there also have been some really amazing global initiatives through the Bond Challenge to the United Nations, where hundreds of countries have pledged to restore millions and millions of hectares of forest across the world. And there's really been a groundswell also of corporations that are doing this too. So for example, through 1t.org, there are lots of companies that have signed on to get behind just doing tree planting in general. But what I really wanted to talk about today was also just the importance of kind of conserving what we already have too. But to I'll basically talk about just the potential of carbon accumulation from these different types of restoration. Both reforestation and conserving existing forests are these natural things that we can use that have enormous potential to mitigate climate change. So, for example, a recent really cool publication on natural climate solutions showed that reforestation in general has one of the highest potentials to just draw down tons of carbon and mitigate anthropogenic climate change. But then also just making sure that we consider to continue to conserve our existing forests is equally as important, and even more important because it's so much more complicated to restore a forest without just letting it kind of come back on its own. So typically conservation is really the #1 thing that we want to do. And then another thing I wanted to mention is that the costs associated with just protecting forests in general are much lower than doing the really active restoration that's very intense. So these basically circles basically are equal to how much money it actually would cost to protect a really large area of forest. And the costs are much lower to just make sure that we maintain the existing forest that we have. So that's really great that all these countries have signed on to try to end deforestation. And then the costs associated with planting trees, while this is a really necessary approach in many cases, are much higher. So we really want to think about just holding on to what we have to start. But also there are these areas that are so far degraded that tree planting is very important. So to bring you to northwestern Costa Rica, this is a dry forest that I worked on for the majority of my PhD. This is a picture of a forest that has been regrowing for about 30 years. So it's very, very slow going. The soil has been very degraded. Many years of cattle grazing and deforestation that occurred probably over 100 years ago really necessitate the active intervention or the tree planting. So really, tree planting can do tremendous things and grow forests back really quickly. And we talk about this as like catalyzing the recovery of these systems. And I wanted to give an example that just shows how dramatic this can be. So a forest recovery project I worked on in southern Costa Rica with Karen Hull and Zach Sahawi, they basically set up some comparisons between just naturally recovering forests and tree planting. And this is an example of what one of these really degraded areas with invasive grass looked like. And then 10 years later, you can see just with tree planting of a couple species, the canopy can be 10 to 14 meters tall. So really, in the right situation, tree planting can be incredible and really just jumpstart the system coming back. And then eventually what happens is with these ecosystems being built back, we don't have to do any more tree planting. The birds and the bats and all the animals that do distributing seeds bring the seeds in and then really make sure that the forest continues to recover on its own. So this is really our goal when we do tree planting. And I wanted to talk a little bit also about the importance of really working with local communities in this work. So I did my doctorate at Estación Experimental Forestal Horizontes, working with Pedro Alvarado, who's on the left here. He's a restoration practitioner. And then my advisor, Jennifer Powers at the University of Minnesota, is in the center. And Milena Gutierrez on the right-hand side was the director of Horizontes at the time. And we all just worked together, just working directly with the scientists and the restoration practitioners to build a project that benefited them and then got us information on how to better restore these systems. And really, this has kind of been the focus of the rest of my work, is making sure that I'm always working with communities, and I've shown that it's so much more important to have communities really building the restorations themselves than coming in as scientists and asking people to do things, because people already know how to do ecosystem recovery. People have been doing this for hundreds and thousands of years at this point. It's just making sure that we're really having these conversations and linking the science and the people that are actually on the ground. That's the most important. So bringing you back to this really degraded forest that we did the work in, basically this is a soil type that when it gets degraded, it has these really large cracks in the dry season and some serious flooding in the wet season. So it's really challenging to restore this. And what we did was just to use this big buzzword that people use a lot, is try to understand how to plant the right tree in the right place. So doing a really large scale species trial and figuring out what species grew the best helped us to then make some suggestions to people that were trying to restore forests in the area and just having some trouble and needing just basic suggestions on how to do this. So we worked with a really excellent group of volunteers and all of the community to come in and just try to see which trees were the best. And then we used this to then do larger scale restoration in the area. And basically forests have really major changes over time. So what this is called is forest succession. And you can see in these early successional areas where after a forest has been cleared, and you have a lot of grass, the conditions are kind of harsh. And then you have some species just come back generally on their own. And then you get this later successional forest where the canopy is closed and basically it's much more of a natural system. But it's really important to think about kind of what the stage of the land is in, and then also just really think about basically if tree planting is necessary in the first place. But when it is, we really want to think about ecosystems that are recovering really slowly, we want to think about growing trees rather than just planting. So a lot of things is thinking about just long term. So if we are to put the tree in the ground, we want to think about how to make sure it's protected over the long term. So this is really the most important thing that I try to think about, is just making sure that the tree has the ability to actually grow, and you might need to do a little bit of maintenance around the base to keep it going, but then making sure that it's going to be there for as long as physically possible is really important. So then I really wanted to highlight the importance of this new tool that Crowther Lab has developed called Restore, to basically see and show how you all could think about what you could do and how you can get involved with basically global restoration. And what the Crowther Lab has really developed and now handed this over to its own nonprofit organization is Restore. So this is a completely open source, basically free for everyone to use a restoration platform. It's at restore.eco, and it's now open for all to use. And the idea is that restoration projects, and also anyone that's even doing a little bit of work in their backyard, doing any type of restoration at all, can basically upload, you can draw a really simple box around an area and then show the area that you're working. And then what's really nice about this is that all the science behind it, there's all these huge global maps that basically can show the potential of carbon accumulation, make suggestions on what type of restoration might be good in that area, and then basically build this whole kind of platform for then all of these restoration organizations and then anyone that's on this to start communicating. So as you can see, at this point, there's almost 70,000 sites that they've already been able to bring together, and the map is extensive across the entire globe. And this is all individuals that are doing little projects in their backyard, big restoration organizations that have been doing restoration for a really long time, and just a whole range of different people that are coming together. And what I'm really hopeful about is that this will start to create communication between all these different groups. And then, for example, I just decided to draw just a little area in my backyard in Zürich. So for example, let's say I was working in this forest, kind of in this box right here. I can get an estimation of like the potential of forest or the ecosystem in there to actually accumulate carbon and what this can do to offset climate change. And then if we zoom out, then I can get an idea basically of all the different people that I might be able to work with. So if you're looking for potentially projects that are already ongoing in your area that you might want to be able to reach out to and start collaborating with, or just to volunteer with, I think Restore is really a really excellent platform that this could be used for, because there are restoration projects around the world, and this database of everyone that's on here is growing really rapidly week to week. And then just to come back a little bit to the science, because this is really my passion, what we're doing is then setting up a network of restoration experiments across all of this area. So we've dubbed this the Crowther Lab Global Experiments Network. And to start, we're really focusing on the tropics and Central and South America, because this is where my colleague, Rebecca Cole, and I have done a lot of work. But then ideally, we're going to be using this to basically do a network of restoration experiments across the world. So what we're doing is we're collaborating with nonprofit organizations and just organizations that have been doing conservation and restoration on the ground, to try to get a better sense of forest restoration outcomes to start. And one of the things is just comparing the act of planting trees versus the forest naturally recovering on their own. So we can see in what instance we might use one of these approaches over the other, or how we can use a combination of the two, basically to have the quickest and best outcomes that are beneficial to communities, and then also just beneficial to just nature recovery in general. Another thing that we're focusing on is developing experiments to pick the right species for the right place, and just to get a sense of what mixes of species are the best for rapid recovery, and then just the function of specific types of forested ecosystems. And then one thing that I'm very excited about that we've just started recently is basically trying to build really simple things that people can do to measure all the outcomes of these projects. So while it's really nice to think of all these technology tools that can kind of help us talk together really easily and collect data. It really is also very complicated when you're in a very remote area to do a lot of these measurements with technology. So what we're doing is really thinking about simple and low cost approaches that pretty much everyone can use to basically monitor the recovery of a forest to start, but then recovery of different ecosystems. And all of these protocols that we're developing are going to be completely free for anyone to use. So anyone that's interested in basically trying to see the carbon capture potential of a couple trees that they planted in their backyard could be able to use these. And then ideally what's going to happen is that all this information will then be fed back into Restore at some point. So we're using this as kind of the ability to then build these maps of global restoration potential and really see, okay, where is it best to focus restoration efforts? And then what is the best approach to doing this? Just so that we can give people suggestions, but then also make sure that anyone that is interested in doing any restoration around the world has hopefully a roadmap to doing that restoration, and that will make it easier for them to kind of facilitate that work. And then hopefully this will continue to scale and we'll get as many people on the platform as possible and be able to actually make sure that we're monitoring and checking to see that all of the countries that have pledged to stop deforestation and over a very rapid period of time, we can actually make sure that that's happening. So, and then also the restoration projects that are offsetting carbon emissions, we can then get a better sense of the scale that it actually is working at. So I think it's just really exciting to think about this as a communications tool that can bring us all together, and then also just so everyone can really get a sense of what's happening in their backyard so they can get more involved.